you so much for joining today's AMFEP webinar on the guidance on the dustiness of solid enzyme products. My name is Camille Windels. I work as a Regulatory Affairs Manager in the AMFEP Secretariat, specifically in the Enzyme Safety Committee. And I'm happy to introduce that we have a 45-minute webinar presentation lined up today. And I'm happy to introduce to you the topics of discussion for today, as well as our speakers. So we have here with us today Merete Simonsen, who will open the webinar, providing some insights into the development of the guidance document, its objectives, and what it entails exactly. Merete has over 30 years of experience within the field of enzyme safety. She is currently the chair of the AMFEP Enzyme Safety Committee, as well as chair of the AMFEP FEDIMA Enzyme Safety Working Group. And she's furthermore co-author of guidelines and peer-reviewed publications related to enzyme safety. Up next, Maarten van Oort will introduce to you the sensitizer release score. Maarten has a PhD in enzymology, and for the last 40 years, he has worked in various companies in research and development roles, always related to enzymes and food and baking applications. Since 10 years, he also has a larger involvement in health and safety issues, also related to enzymes specifically. And finally, we will delve a bit deeper into enzyme safety measures presented to you by Ilse Tuinman. Ilse holds a PhD in aerosol science and has worked at TNO for 20 years as a researcher on respiratory protection and aerosol detection and analysis. She is a member of the working group that wrote the standard for nano-dustiness, and since 2023, she is the OSH lead at IFF and vice chair of the AMFEP Enzyme Safety Committee. After some concluding remarks presented to you by Merete, we have foreseen also a 50-minute Q&A session for you, where you will have the opportunity to ask some questions. Please note that questions can also be can be submitted via the Q&A option in this webinar, but also can be submitted via email after the webinar, should more questions arrive after. Please also note before we get started that this webinar session will be recorded, will be made available on the AMFEP website afterwards, and we will also circulate a link so you have access to the recording. With that said, I'm happy to pass on the words to Merete to get started.
Thank you so much. Generally, need to start from the very beginning. It's well known fact that enzymes can cause respiratory allergy if inhaled. This fact was discovered more than 50 years ago when the first industrial enzyme products were put on market. This discovery was a big threat to the enzyme industry, and since then we have constantly worked to develop more safe products and to communicate the best principles for safe handling of enzymes. The best prevention of the risk is to ensure that enzyme particles do not become airborne. For solid enzyme products, this means that they should not create dust when handled. However, measuring the dustiness of enzyme products and translating this into exposure levels during handling has over the years been a very big challenge. Nevertheless, AMFEP decided in 2020 that a task force should be established to solve exactly this challenge, to establish a method for measuring dustiness of solid enzyme products and to set boundaries using this method in order to avoid high levels of airborne enzyme dust during handling. The result of this work was published in October 2023 in a guidance document on the dustiness of solid enzyme products. We are aware that only a few laws and regulations are in place to set limits for the level of airborne exposure, but these limits, they are there, and we need to respect them in order to take care of the health and safety of our downstream users and to protect our business. The issue has been how to supply enzyme products that are sufficiently low dusting to provide a safe working environment. And this is what this guidance document can help you with. Next slide, please. So in AMFEP, we have as part of our statutes that members are committed to work towards eliminating dusty enzyme products from the market to reduce the risk of sensitization by inhalation to an absolute minimum. So this commitment is part of the DNA for AMFEP members, but in some cases, it's been a challenge to fulfill this commitment until this guidance document was published. So from now on, all AMFEP members have a method to test the dustiness and thereby the safety of their products. We should all keep in mind that the regulatory landscape is constantly changing and that authorities have respiratory sensitizers like enzymes on their radar. It is therefore important that we demonstrate safety of our enzyme products by putting only products on the market that can be handled safely. Next slide, please. As you probably are aware, the guidance document is a technical document which may not easily be read by everyone. Therefore, in addition to the guidance document, we have provided a short guide in layman language and also an FAQ document. Both the guidance document and the layman guide and the FAQ can be found on the AMFEP website. And on top of this, we are now hosting this first webinar for AMFEP members. A second webinar will take place in September targeting AMFEP downstream users, and an announcement for that webinar will come later. Next slide, please. Generally, product stewardship is an obligation for all manufacturers of enzymes, including AMFEP members. Good product stewardship is, among other things, about supplying safe products to the market and about communicating how products should be handled and which precautionary measures should be in place in order to ensure a safe working environment. In this webinar and in the guidance document, you will see that the guide requires AMFEP members to ensure the right safety communication to their customers. That is, for each product, it should be communicated which precautionary measures will be needed in order to handle the specific product safely. More will come on this as I now give the floor to Martin.
Thank you, Merete. I will say a few words about this hopefully well-known sensitizer release score, well-known by now. The task force that Merete mentioned was given a number of mandates. And the first mandate was that the task force should develop a method to measure the potential of solid enzyme products to release inhalable enzyme dust. And that is what the task force has done. And the method has been called the sensitizer release score. And I will explain in a minute what it exactly means. But there was let's say, an additional demand that the method had to be useful to all members of AMFEP. And even to, let's say, companies who are not members of AMFEP, but simply are producing or using enzymes. But also companies who do not have an option for enzyme exposure measurements, or companies who do not have any knowledge on specific enzyme activities, or do not have extended laboratory facilities. So it had to be a method that could be used by, in principle, everybody. And that method is now what we call the sensitizer release score. Furthermore, of course, you may have an interesting method that gives you quantitative data, but you need also to have an idea what do these data mean. So the mandate was also to provide provisional boundaries for the dustiness of solid enzyme products. And that's also what the task force has done. We have set boundaries for safe products, for intermediate products, and for unsafe products, as you can see on the right in green, yellow, and red. And then finally, we had to develop a guideline how to act according to these provisional limits. And that's the guideline that Merete already mentioned. The task force was made by representatives from IFF, DSM, AB Mauri, and Novonesis. And a few of them are now presenting. The task force was a bit bigger than the presenters here. But the first thing the task force did was to evaluate methods for assessing dustiness in general. And among a number of different possible methods, we selected the Hoybach-1 method. And for good reason, simply because this method is well known. It has a long history of use for dusty products and for enzyme products. And it's also a relatively simple method which is widely available. Then what we tried to do was to find a correlation between Hoybach dust levels and exposure, of enzyme exposure. And that was actually quite a challenge, simply because there are many different ways of handling enzymes. There are many different conditions under which enzymes are being used. There are different methods in which enzymes are being used. And what we said was a very detailed protocol on measuring Hoybach and measuring exposure. So we, each of the participants of the task force provided a number of products. From all these products, the Hoybach dust level was measured repeatedly. And with all these products, we also measured exposure during handling of these products, enzyme exposure. And all these data that came out have been analyzed by expert statisticians, external even of this task force. And wonder boven wonder, they found a really good correlation between Hoybach dust levels and the enzyme exposure. And that is illustrated in the pictures that you see. And actually, because of this wonderful correlation of higher than 0.9 or close to 0.9, we actually developed this so-called SRS score. But as you of course realize, Hoybach 1 measures total dust, and we were looking at enzyme dust exposure. So what we actually did was to include the enzyme concentration or the fraction of enzyme protein in the dusty product, and together with the Hoybach dust level, this active enzyme protein fraction gave us the SRS score, as I will show in a minute. Based on, let's say, known data on enzyme levels, we were able to determine SRS boundaries, as I have just shown, and also actually exposure boundaries. So, okay, then we have a method and we have boundaries. But then, of course, what to do with it for enzyme manufacturers or formulators. What we have made is a decision tree, a simple one, and as I will show you in a minute, also a complex one. But the simple one actually takes a stepwise approach to calculate the SRS of a product. And based on the levels of SRS, green, yellow or red, below 10, between 10 and 250 or above 250 parts per million, we need to decide, we said the manufacturer needs to decide whether enzyme exposure measurements are needed. And in principle, they are certainly needed when we have products with an SRS above 250. They are not needed when we have an SRS below 10. And in between, it is a bit depending on the level. These SRS levels of below 10, between 10 and 250 and above 250 have been related to enzyme exposure levels, as you can see on the right. So a low risk product with an SRS of less than 10 indicates, as you will probably realize, a well-designed product with airborne enzyme levels less than 60 nanogram per cubic meter. And you all know that this level of 60 has been already for a long time been assigned for, let's say, safe products. Of course, a bit discussion on whether 60 nanogram per cubic meter means ceiling values or stale values or time-weighted average values. But apart from that, 60 is in general considered as a low-risk level. For the medium and for the high risk, we also were able to establish exposure levels related to the SRS levels. and these are listed here in the yellow and the red boxes. An SRS value between 10 and 250 is related to exposure levels between 60 and 6,000 nanogram per cubic meter. And higher levels, high risk levels, SRS above 250 relates to airborne enzyme levels of more than 6,000 nanogram per cubic meter. And then, of course, we have tried to relate these levels, low, medium, or high risk, to the necessary control measures and safety measures, as Ilse will talk about later. The more complex decision tree, as you will have seen in the guidance document, is a bit, of course, comes to the same conclusion, but shows in detail how to reach that. So again, it starts with measuring the SRS, which is the Hoybach level multiplied by the fraction of active enzyme protein. And when this is below 10, we can say that these products can be handled, provided general safety handling practices are in place. And these are explained more in table 2, as Ilse will show you later. When the SRS is between 10 and 250, and then guidance needs to be provided to the customers on safety controls during handling these products. And also these safety controls are listed in table 2, as you will see. And that means if these safety controls are in place, then these products can be supplied to the users. The problems, of course, occur when the product, an SRS of more than 250 is found. In that case, we strongly recommend air monitoring, enzyme exposure measurements. Of course, we realize that not everybody is able to do that. If companies are able to do exposure measurements and they find exposure levels in the safe area, then automatically the product can go to the green zone. If not, then we need to provide strict safety controls during handling of these enzymes. If a company is not able to do any dust measurements, enzyme exposure measurements, then of course we strongly recommend external occupational hygiene experts or health and safety experts to do this, or to actually at least make this possible. If, in spite of all these strict measurements, we are not able to fulfill the safety controls, then the product should not be sold, or may not be sold, may not be used. Merete also talked about the stewardship and the communication requirements, and these are actually going exactly in the same order. If we have a product which is in the green zone, safety controls can be provided. Of course, they still need to be very clear and specific communications to the downstream users, but in principle the product can go. If safety controls, as you can see in table 2 later, can be provided very clear and the downstream users can be taking these up, then again the product can go. If the safety controls cannot be fulfilled, then the product should be redesigned or completely abandoned, or different application processes need to be found. And this is, of course, part of the stewardship towards the products. There is a number of other aspects that are important here, and that is simply a bit of, let's say, understanding. This is partly very quantitative science, but it's also partly estimates. And I'm just trying to illustrate that here by talking about the volume. You can have a very small volume of enzyme product, a few gram or maybe a kilo, with a high risk SRS, but that may be much easier to handle than 1000 kilo of, let's say, a lower medium risk product. The amount of enzyme that can be dispersed may be the same in both cases, but the smaller volumes are much easier to handle. So that means that a high risk SRS does not necessarily mean it cannot be handled, but it must be handled in very small volumes. If we say, okay, we have a green product and we need to take only the necessary very simple safety precautions, it does not mean that these very simple safety precautions can be abandoned. If there is no ventilation or limited ventilation, or there is not sufficient cleaning or other things, dust concentrations may build up. And that means that even the simple things like ventilation or cleaning are strongly advised, even in the case of low-risk products, simply to prevent building up of unwanted concentrations. I'm lost. The exposure monitoring is not just to see if a product is good or good enough to be sold or to be handled. It's also needed to see whether controls that are put in place, engineering controls or administrative controls or anything else, is effective or not effective. That means that proper analysis, proper enzyme exposure measurements are still needed a few times in regular intervals, simply to see if all the controls are still relevant, are still in making the ways of working better or not. And of course, we realize that not everybody is able to do this, but people trained in occupational health and safety, occupational hygiene, they can integrate all these aspects, including SRS and safety measures and controls. They can put it in place. They can make exposure monitoring schedules if you want. And that means that such people can provide a real safety assessment, which is needed when high-risk products are considered. And then a last thing, and that is an interesting one as well, effect of dilution. We are looking at inhalable enzyme dust, and that is causing, has a potential to cause sensitization. And we have said this SRS is dependent on the active enzyme protein fraction. And that means you can dilute it, thereby getting a lower SRS. You can simply take a concentrated product, dilute it with a carrier which is dusty or which is less dusty than the product itself. That has some consequences. And we have given here two examples. We have a product produced by someone which is quite concentrated and has an SRS of 4. And that is measured in such a way that the Horbach was measured, which is quite low, 20 milligram per kilo. And it has 20% active enzyme protein or 0.2 fraction enzyme protein. And 0.2 times 20 is 4. That is simple. But then a formulator is using this enzyme product and is blending it, 20% of this product, with 80% flour, which means he dilutes it 5 times. The resulting product, or the flour that is used, has a dustiness of 300 milligram per kilo. Then you can measure the diluted product again using Horbach, and you see it has a dustiness of 250. But since the product is diluted 5 times the 20% active enzyme protein goes to 4%, times 250, you get an SRS of 10. And then you think, hey, shit, my product is becoming less safe, still safe enough, which is, of course, a bit strange. It is not expected that the diluted product is less safe, simply because it's diluted with something which does not contain active enzyme protein. Of course, when you mix it intensively and you break down granules, you may get more dust from the enzyme itself. We don't expect that. So in such a case, when you have a dust of, let's say, you dilute an enzyme product with a dusty carrier diluter, then you may say, okay, I'm not going to look at this SRS, but I can take a reasonable, not very conservative approximation to say that simply use the dilution factor. You go from 5 times diluted to 0.8, because you have diluted with something which is not at risk. The other way around is a bit more quantitative. This is a product which has an SRS of 40, dustiness is 200, again 20% active enzyme protein, 200 times 0.2 makes 40, and this is mixed with grains with dustiness of only 30. The resulting product has only a dustiness of 75, and the protein is diluted 5 times, so 4% active enzyme protein, 75 times 0.4 gives an SRS of 3. This is very clear example of that dilution can strongly reduce the risk of a product. And also a very conservative approximation is that instead of calculating the SRS, you can simply say, oh, I take the dilution factor of 5, I have an SRS of 40, the resulting is 8. You can see that the product is safe, less than 10, and you don't have to do all the measurements and calculations. But of course, you must know what your diluter is and how often you dilute. But it shows that this sensitizer release score is very strongly dependent on the amount of enzyme protein present in a product, and also very much dependent on the dustiness of that enzyme product, and much less on the dustiness of a carrier or diluter. And I think that is what I wanted to say about the SRS. And then I hand over the floor to Ilse.
Thank you, Maarten. So this final part of the webinar focuses on safety measures and the relation between recommended safety measures and the sensitizer release score specifically. First, I will go back to some background information that is very important for understanding. As Merete has mentioned in the first part of this webinar, all enzymes are category 1 respiratory sensitizers. However, we know from medical surveillance that generally industrial workers who work at manufacturing sites where the concentrations are extremely high, and of course measures cannot have been taken yet to make the enzyme into a safe product. There we find sensitizations. Rarely even there do we find allergies, but it does occur. Also in the detergent industry, we know that there are very few sensitizations even, because they took very rigorous measures to make everything safe. Where we know that occasionally allergies are reported is especially the baking and the feed industry. And that is due mainly to the fact that in those industries, the enzymes are handled manually, which means that the risk of exposure is highest. Now, when you think of exposures, it is important to be aware that the enzyme dust that you can inhale and that can deposit in your lungs, where it can be taken up by the body and cause sensitization, because the body recognizes the enzyme as foreign, and therefore the immune system is triggered. This enzyme these particles are so small that you cannot see them. And for those of you with good eyes, there are 5 little dots, and respiratory enzymes that are in the air and can be inhaled are smaller than 1 hair width and smaller than that tiniest particle that you see depicted here. That means you cannot see it. Visible dust is a good indicator that there will also likely be airborne dust, but it is not the dust that you can actually inhale. That you cannot see unless the concentration is extremely high, like cigarette smoke close to a smoker, and then if the concentration is that high, you are in real trouble. Now we go to something that is very well known to people in health and safety, which is the hierarchy of controls. And for those of you who do not work with it that often, this is a reminder that the most desirable and most effective way to prevent exposures is simply replace hazardous products. Now, we cannot replace enzymes, but what we can do is replace dusty products with low dustiness, encapsulated products, etc. Secondly, we have engineering controls, and the following slides will focus a lot on those. Administrative controls are equally important, especially training of the workforce, making sure that they know what they are working with and what the safe work practices are to prevent exposures, and last but not least, respirators, personal protective equipment. Ideally, you would want the situation to be so that PPE is not strictly necessary, but even when it is not strictly necessary, we all know that it is very uncommon to not wear any gloves, etc., to protect our workforce. As I said, of course, the replacement of safe products means that we look at products with a low SRS, but engineering controls are almost equally important. And in this slide, you see a couple of examples of very common processes in a factory or even a bakery where you can reduce exposure by using isolation, most effective, enclosure and ventilation, or least effective, but still very important and very commonly used, local exhaust ventilation. How does that relate to the safety sensitizer release score. When you think about a product with a sensitizer release score of 250 or higher, it is very difficult to keep your workers safe unless there is full isolation. And full isolation can mean, for small amounts, a glove box; for larger amounts, maybe even enclosing a full small part of the process is a glove bag. I have seen a separate room at under pressure with workers in full safety gear, normally in low-income countries, but also in the pharmaceutical industries this happens, but rarely is this a good way to work. And you can see when the project becomes safer and we go from red to orange to yellow, we can use more normal safety measures, fume hoods, laminar flow cabinets for small volumes, maybe a ventilated enclosure for your bags on a belt, vertical lamella, simple box around transfer points or sampling points, and finally movable LEV, which is not often as effective as normal ventilation because the hoods are tend to be a bit small, not covering the entire release, and also because they are movable, they may not be in the precise place where they are most effective. And knowing about these recommended safety measures for the different SRS classes, we also need to communicate that to our customers so that we make certain that our customers also work safely with our products. And again, for the green, the safest products, that means you can just point them to the AMFEP safety webinars, sometimes company safety webinars, maybe AISE, which has a lot of good information about safety measures and ventilation. And you make sure that the customer is aware of the most important administrative controls. You give them a good safety data sheet, and they're on their way, and nothing bad should happen. When you have a product with a higher SRS and you're in the yellow class, good product stewardship means more communication with your customer, maybe check in a web conversation, that they are well aware of what they're doing. If possible, you could do a site visit, pointing out places where improvements or better processes, just work processes, can help. Maybe point them at better respirators or ways to use them, whatever. Train the trainer. Often the communication will be with the local the local manager and an HSE person or an industrial hygienist. And of course, if you have a very dusty product with high concentrations of enzyme, you have a more intense conversation with your customers. Maybe you can check with them if a lower risk alternative is available and suitable for them. Sometimes it is not. And then You check with them that they understand how to perform a quantitative assessment. You point them to the necessities. Maybe you help them with analyzing air monitoring. You point them to medical surveillance and how that is performed. And all our AMFEP guidances cover that, but nevertheless, personal one-on-one conversations are important. Now, all this has been, or maybe not all, but we have tried to be as comprehensive as possible, providing that safety information related to procs in table 2 of the guidance. And procs, for everybody who has worked in making chemical safety reports for ECHA, is a very common way to say, to classify your process as completely enclosed, almost completely enclosed, proc 2 and 3, less enclosed, maybe a lid, but not, occasionally open something. You maybe have manual addition of certain ingredients, whatever. So this part is very much for the professional and not so much for the general salespeople, etc. But it is very important information. And as I said, we have tried to be as comprehensive as possible to make certain that people understand what type of measure is required to work safely with certain types of enzyme products. And of course, this always is dependent on volumes and experience of the workers, etc., etc. Finally, I want to say a few words, only a few, on respiratory protection. This is mainly to remind people that that is the backup that we tend to use. Always use respirators with P3 filters. Those are tend to be higher end FFP masks. That is the minimum, and they should be used mainly as backup. So the process should be inherently safe, but in case it's not, or something happens, this is always a good way to make certain nobody gets overexposed. Half-face masks, they should have the same type of protection that the filtering face pieces do, but they tend to be a little bit better at protecting. Then, of course, you have the full face mask, which offers a much higher level of protection. And very importantly, because you inhale via these filters, there is a under pressure in your mask, and leakage can occur if the mask doesn't seal properly on the face. And if especially a male is not clean shaven, even a stubble will cause leakage. And if a person has a real beard or whatever, or mustache or whatever, I advise, and everybody advises, to use powered air purifying respirators, because there the air is pumped into the mask via a filter, so you have overpressure and no leakage should normally occur. And enzyme safety training is very important. Respiratory protection only works with well-trained people and generally with oversight, people monitoring that very closely, because it is so common that people put those masks half on their face, or they scratch their nose and they don't close it really well, and there are leaks everywhere. And your respirator doesn't protect you if it doesn't seal well on the face. So very important to train people well, so that they are aware of that and that they keep using their respirators properly. And with that, I give the floor back to Merete Simonsen to conclude.
Merete, you're muted.
Thank you, Camille. Thank you. We now come to the end of the presentation, so it's time to wrap up. I think by this guidance, we have now provided you with a tool to comply with this part of the statutes from AMFEP about eliminating dusty enzyme products from the market. We have provided in this guideline a simple method for measuring the dustiness of enzyme products, and that method also correlates to the exposure that can be seen when handling the products in the production plants. The SRS has been established with boundaries so that we know what sort of risk class we are in, green, yellow, or red. And we have also provided you with a tool in Table 2 of the guideline to determine the necessary safety precautions that will be needed in order to handle your specific products in a safe manner. And lastly, but not least, the very important requirement for communicating the necessary safety precautionary methods to the downstream users, so that they can actually come in a position where they can handle your product in a safe manner and make sure that they have a safe working environment. So I hope by this webinar that you have now been feel that you have been introduced to the guideline. Should you have any questions, you are welcome to come forward both now and also at a later stage. So back to you, Camille.
Yes, thank you, Merete, Maarten, and Ilse for your presentations and contributions. It was very interesting to listen to. A final comment from my side as well is that we had this webinar today specifically targeted towards AMFEP members, but we also plan on having a second webinar on the 23rd of September, targeting downstream users specifically. There will be some overlap in terms of content with the webinar that we had today, but we plan to also tackle some very practical examples on how to interpret and apply the guideline. So that is scheduled for September, and we will also circulate a save the date communication for this webinar as well. So that's a quick update there from our side. And then finally, we have a couple of minutes left. If there are any questions, you can ask directly to the presenters. I have not, or submit them in the Q&A option. I have not, if not mistaken, not received any questions so far, but you still have a couple of minutes to ask your question directly, or as Merete mentioned, submit them via email to the AMFEP email address. See, we have a question from Alessandro. Please go ahead.
Yeah, sure. Thank you. I'll start by saying excellent presentation. Thank you very much. Very pragmatic approach that I had already read. So fantastically explained. One thing it has always puzzled me in the guideline is the choice to say that exposures that are above the limit or that are estimated above the limit and up to 100 times the limit have a medium risk. So you show that in a slide at a certain point, 60 to 6,000 nanogram per cubic meter will match medium risk. And that doesn't seem to me to match the definition of occupational exposure limit, which is meant to be the threshold of what is acceptable in terms of risk. So I would assume that anything above the limit would have to be a high risk. So I would be curious to know what has been the reasoning of the working group to say that that is a medium risk, and how you came to that conclusion. Thank you.
Let me try and give a first shot on that. I think it's not like we find that up to 6,000 nanogram per meter cube is in any way an acceptable exposure level. It simply means that going from within the yellow zone, so from 60 to 6,000, you have the option of reasonable safety precautionary measures to control the exposure. So you have the potential to bring that exposure down by providing the right ventilation, by using respiratory protection, by making sure that the handling is done correct, and so on. So the 6,000 nanogram per meter cube is not in any way meant as being acceptable, but it is the expected exposure the exposure that you should expect when you calculate the SRS score. Your job is then to provide those precautionary measures mentioned in Table 2 to reduce the expected exposure level to something reasonable. I don't know if Martha has something to...
Maybe I may add something there. This was the expected exposure in a certain type of handling without any precautionary measures. So it is not a generally expected exposure. It was the expected exposure for a product of that type when manually transferring in a non-dedicated facility. And then also of a certain amount. So that is what we used as the standard, and it is by no means, as Merete explained, that we think that an exposure between 60 and 6,000 is acceptable. So I hope that explains it a bit more clearly, where that 60 and 6,000 come from.
Anyone else has a question? I don't think so. Well, in that case, I would like to thank everyone for joining our webinar today, for your participation. It's very much appreciated from our side as well. As mentioned, this webinar was recorded and will be made available on the AMFEP website, and you will also receive a link to the recording as well. So thank you very much for joining, and I wish you a very pleasant rest of the day. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.